Did Japan invent the bullet train? Yes. Did America invent the skyscraper, the solar panel, and the electric vehicle? Yes. France and Germany gave the world high-speed rail. The credit for the original ideas belongs exactly where history placed it. When the Shinkansen first pulled out of Tokyo in 1964, the world watched a passenger train hit 200 kilometers per hour and called it a modern engineering miracle. But then a strange thing happened. The nations that drew these blueprints largely stopped building them. A handful of short rail lines were laid. A few records were slowly broken. We accepted a reality where the first working version of a technology was treated as the final version, bogged down by budget debates, environmental impact assessments, and a pervasive belief that what we had was simply good enough. Then China entered the room. It is easy to look at a blueprint and duplicate the math. It is entirely different to duplicate the will required to execute that math at full national scale. That kind of ambition has to come from somewhere else entirely. The following chapters document what happens when a civilization of 1.4 billion people decides that the first version of something is never the final one, and that the only relevant question is how far an idea can actually go. This map tracks global high-speed rail. Japan built 3,000 kilometers in 60 years. The rest of the world combined barely cracks 20,000. In 15 years, China laid over 45,000 kilometers, more than double the entire globe's infrastructure, running thousands of trains every day at 350 kilometers per hour, with 95% punctuality. The same pattern applies to how we build vertically. The skyscraper is an American concept, a steel-framed invention born in Chicago and perfected in New York that dominated the skyline for the entire 20th century. In 1990, China had almost no modern high-rises. Today, the city of Shenzhen, a metropolis that did not even exist 40 years ago, contains more super-tall buildings than the entire United States. They achieved this through modular prefabrication. By manufacturing components in a factory while the foundation is poured, they condense construction timelines to numbers that sound impossible. In 2014, a Chinese company used this method to build a fully functional 57-story tower in exactly 19 days. They applied this same velocity to extreme engineering. European designers pioneered the suspension bridge, yet today, China holds all 10 records for the longest suspension bridges on Earth. When they looked at the concept of a glass bridge, they didn't just build one, they built hundreds, suspending transparent walkways between sheer cliff faces hundreds of meters above the valley floor. These are not isolated novelty projects. Connecting remote river gorges and linking distant cities with a 2-hour train ride means a factory worker in Wuhan is now part of the same functional labor market as an office in Shanghai. The infrastructure completely reorganized the economic geography of 1 billion people. In 1954, scientists at Bell Laboratories discovered how to convert sunlight directly into electricity. But for 50 years, the solar panel remained a highly expensive technology, serving as a political talking point rather than a viable energy solution. When China applied their vast industrial capacity to the supply chain, the cost of a solar panel fell by 90%, making it the cheapest electricity source in history. They then used these panels to build massive regional-scale desert installations, like the Tanger Desert Solar Park in Inner Mongolia, a facility covering over 1,000 square kilometers of otherwise unusable terrain. We see the exact same dynamic with transportation. Silicon Valley proved that an electric vehicle was a desirable alternative to the internal combustion engine. China took that proof of concept and built an entirely new industry with over 800 individual EV manufacturers, producing everything from $10,000 city commuters to high-performance luxury sedans. To keep those vehicles moving, they simultaneously built out the necessary charging grid. Today, China operates more public fast charging stations than every other country combined. The West proved that clean energy and electric vehicles were good ideas. China's industrial scale ensured that global adoption was mathematically inevitable. For almost a century, European shipping defined the benchmark for global trade. Logistics firms and economists looked at Rotterdam as the gold standard of what a heavy port operation should look like. By 2004, Shanghai had passed Rotterdam. Today, China operates 7 of the 10 busiest ports on Earth. Facilities like the Port of Shanghai process tens of millions of shipping containers a year, using deep-water berths and automated terminals, where massive cranes load cargo without a human hand ever touching a steel box. To run that level of automation with imperceptible latency, you need a massive wireless network. While the West spent years mapping out gradual deployments, China built out 3 million 5G base stations. For comparison, the United States currently has roughly 100,000. The starkest example of this deployment gap is nuclear power. It is an American invention that led the world's energy generation for decades. But after high-profile accidents at 3 Mile Island and Chernobyl, the technology became politically toxic. Western nations shut down their fleets. China did not abandon the technology. They took the baseline engineering, solved the specific safety flaws by adding advanced passive cooling systems that can safely shut down without human intervention, and started pouring concrete. Today, they have roughly 25 reactors under construction, more than the entire rest of the world combined. Industrial supremacy belongs to the civilization willing to absorb political friction and bureaucratic fear to finish the work the original inventors abandoned. Confronting the record of the last 30 years requires looking past the common accusation of copying. Duplicating a drawing is easy. Building 45,000 kilometers of high-speed track, operating fleets of tunnel-boring machines, assembling the largest dams in history, and collapsing the global cost of solar panels by 90% is an entirely different level of execution. We have now reached a point where the engineers from the countries that invented these technologies are traveling to China to study how their own concepts operate at maximum scale. Executing an idea so far beyond its original vision that the creators return to study the results defines a specific stage of development. We call that mastery. The global advantage in the 21st century does not belong to the nation that sketches out the smartest blueprint. It belongs to the nation with the factories, the workforce, and the relentless drive to actually build it.